Welcome to your second half of your spring semester test review. Please check your dates for your semester tests. This is an assignment will be due and you need to turn it in on the day of your test. Take a look at number 21. Before we start, let's review a few formulas that might help you. Okay? Compounded interest. The formula for that is A is equal to your principal, 1 plus R, which is your rate, over your K. Tells you how many times it's compounded. K times the T, which is your time. For continuous rate, it is A is equal to your principal times E raised to the R over T. R is your rate, T is your time, E is a constant, P is your principal. For growth and decay, it is A of T is equal to A, 1 plus R raised to the T. Now, and then there's another one. Y, this is your growth and decay for exponential. A times B to the X. If your B is greater than 1, that is a growth. If your B is less than 1, that's a decay. Okay? So before you start, make sure you have this part written down somewhere to kind of help you. All right, let's take a look at number 21. Your money invested is $5,000. So this is your P at an interest rate of 6.72%, which is 6.72. A percent is out of 100, so that comes out to be 0.0672. Compounded annually, that means it's every year. So this is your T. The question says, write a function to represent the worth of the account at any time T. So the formula we're going to use, since it's compounded annually, is the formula right here. Okay? So you're just going to plug it in. A is equal to your principal. What is your principal? 5,000. Parentheses. 1 plus your rate, 0.0672, compounded annually, in parentheses, 1 times T, because we don't know how many years, but it's compounded once a year. So there is your function that represents all that information. B, how many years will it take for the account to quadruple? Quadruple means times 4. So your principal is going to be 5,000 times 4, which comes out to be $20,000. So that is going to be your A. That's your final amount. So you're going to plug in 20,000 equal your principal. This is what you started off with. At 1, anything over 1, it's itself. Okay? Times 1 times T, and we want to know T. So you can go ahead and just use the math that you have learned. Now, you can use your calculator like we've done before to teach you that, but you guys already know logarithm and exponent, so we're going to use that to solve our answer. All right, so I'm going to rewrite this. So you got 20,000 is equal to 5,000, 1.0672 raised to the T power, okay? I'm going to divide by 5,000 first. What you do to one side, we do to the other. And if you will look, get my calculator, 20,000 divided by 5,000. 3 zeros can wait. So 20 divided by 5 leaves you 4, is equal to 1.0672 raised to the T, okay? Notice the T is in your exponential power. So what you can do is you can use your logarithm. So here's your base, raised to the X is equal to that. So I'm going to rewrite it to where you are more familiar with it. 1.0672 T is equal to 4. Now let's go ahead and convert that to logarithm. So log of 1.0672, okay, raised to the 4 of 4 is equal to T. This part, my apologies, here's your base, 1.0672 raised of 4 is equal to T. You can solve for T. All you have to do is plug this into your calculator. So T is equal to, alrighty? Now, remember you can do alpha window, but since I have a TI-83, I'm not going to use an alpha window. I'm just going to change it to the base of 10, so I'm going to put log base 4 divided by log of 1.0672, so I'm going to use base 10. So log of 4 parentheses divided by log 1.062, it's 1.0672, my apologies, in parentheses. So how many years is that going to take? It is going to take 21 years. So there's your solution for number 21. Okay. But on a TI-84, you can just use the alpha window. All right. 22. On 22, you got a principal of 20,000. Let's read it. It says, if the money given is invested into an account that compounds semi-annually, that means twice a year, at 5.7% interest, which is 0.057, will be the equation for the amount of money in the account. So we're going to use our compound. So A is equal to, principal is 20,000, parentheses, 1 plus 0.057 divided by 2, raised to the 2 times your T. So there is your equation to help you. Part B says, how much money will be in the account after 20 years? So there is your T. So A is equal to 20,000. Okay? So this is the same thing as 1 plus, I'm going to go ahead and do that into my calculator. Let me get out of this one. Clear. So we're going to put 0.0572, apologies, 0.057 divided by 2, okay, plus 1. That comes out to be 1.0285 raised to the 2. What is your T? 20 years. And you can just plug that into your calculator. Order of operation matters. So 2 times 20 is 40. So I'm going to take this number, raised to the 40, okay, times 20,000. You can write it all at one time if you want. So how much money will be in the account after 20 years? It will be $61,546.28. So that's the amount you will have at the end. Part C says, how much money is given into an account that compounds continuously? Well, if it's continuously, you're going to use this account right here, this formula right here instead. Okay? So here's that formula. Okay. How much money is given in that account at 5.6% interest, which is 0.056? What would be the equation for the amount of money into the account? So A is equal to P times E raised to the RT. So A is equal to your principal. What's your principal? 20,000. E raised to the rate of 0.056 at T. And we don't know what T is, okay? Let's look at D. Let's plug this into D. Sarah, can I have my yellow, please? Yellow calculator. Okay, let's look at D. How much money will be in the account after 20 years? Well, let's plug it in. So A is equal to 20,000 E, 0.056 after 20 years. And you can type all that into your calculator, okay? So let me show you how to do that. I got the TI-84 now. So here we go. You can type all that into your calculator just like you see it. So 20,000, okay? There's your E right here. The E is right in front of the division sign, so you can use that. Second E raised to 0.056, okay, times 20. So that will give you $61,297.08. So you can type all that into the calculator. Which account is better for the first 20 years? Well, if you compare the two, do you see how you make more money with the one that's compounded semi-annually? So I would pick that one instead of the one that's compounded continuously. Compound semi-annually. You make more money that way. So I would pick that one. Compounded semi-annually. Okay? Now, 23, we are starting to solve our equations. And if I were you, I would use the TI-84, but you can always change your base to TI-80, to a base of 10 if you have a TI-83. Now, we are going to solve. You might want to use this yellow sheet to try to help you and make it a lot easier on number 23. I'm going to rewrite this first to get rid of my fractions. So you have 16 negative 3n is equal to 64 to the negative 1. Because right now it's understood to be 1. Moving it up becomes a negative 1. Look on this sheet. Where do you see a 16 and a 64? Right here. 4 will be the same base. So I'm going to rewrite this one here as 4 to the second. 4 squared is same thing as 16. Bring down your negative 3. 4 to what power is 64? 4 to the third. Bring down your negative 1. You see how they have the same base? Cancel those out. So now you just distribute. 2 times negative 3n is negative 6n. 3 times negative 1 is negative 3. Solve for n. Divide both sides by negative 6. N is equal to 1/2. Okay? Number 24. To complete 24, subtract 3 first. So now you have 10a is equal to 84. Now notice the location of your a. It's in exponential form. The inverse of exponent is your logarithm. So I'm going to rewrite this. All right, so you're going to take log base 10 of 84 is equal to a. You see that right there? Solving for a, you can plug this into your calculator. All right? Now, if you have a TI-83, you would rewrite this into the same base. You would convert this. So on your calculator, put log base of 84 divided by log base 10, and that will give you your answer for A. But if you have a TI-84, you can just type that in. You type alpha, window, see how it says log base, number 5, okay? And then plug in 10, right click to 84, and A comes out to be 1.924. And there you have your solution. Number 25. You are to solve each equation. We're solving for V. V is in the exponential position, so you have to rewrite this. I will use my log to help me. So, you'll have log base 9. Remember how I keep showing you that rotation? Of 45 is equal to 6V. How do you solve for V? You divide each side by 6. Okay, see how that cancels out? Now you can type that into your calculator, so you'll have, let me clear that. So you type alpha window, number 5, base is 9 of 45, right click, okay? Divided by 6. You could push equal, then divide it by 6, or you can do it right now. That comes out to be 0.2887. And there you have number 25. Number 26. We have an E, so now we're going to deal with a natural log, but you want to set this by itself first. So you're going to add 7. So e to the negative 7m is equal to 99. Okay? Just like before, instead of using log, I'm going to use natural log because I have a base of e. So you're going to have natural log of 99 is equal to negative 7m. Okay? This right here is the same thing as e to the 99. It could be something like this. Okay. You see that? So instead of writing log base e, I'm going to change that to natural log. All right, divide both sides by -7, and that'll give you your final answer. On your calculator, the natural log is by the 4, so natural log of 99 parentheses divided by -7. Don't forget your parentheses. That comes out to be negative 0.6564. Okay, so there you have it. Calculator work. 27. We are going to write each in a standard form. That basically means you want to write from the highest degree to your lowest, and then you are going to just multiply it out. So take a look. X minus 2, right? I'm sorry, x equals 2. This is the same thing as x minus 2. It's a positive number. Multiplicity of 2 means you have it twice, so you have always just take the opposite, -1/2, x minus 1/2, just like that, okay? Now, I don't like to deal with fractions, so what I would do is, you see how you have denominator? If I were to rewrite this and set it equal to 0, it would look something like this. So x minus 1/2 is equal to 0. And what you would do is, you could move that over, so you have x is equal to 1/2 times 2 times 2. So 2x is equal to 1, okay? And then you would subtract 1, so 2x minus 1 is equal to 0. So if you wanted to set it equal to 0, you would actually have to just rework. So instead of doing that, you can just take the opposite. All right. So what I'm actually going to do is I'm going to move the 2 to the front of the x, okay? Basically, this is what you are doing, just a little shorter version. All right. So now you have x minus 2 times 2x minus 1 times 2x minus 1. Right there, I got rid of my fraction. So next part, you can either multiply these two together first, or you can multiply that one next. Since these are alike, I'm going to take care of that first. So I have x minus 2, okay? So 2x times 2x is 4x squared. 2x times -1 is -2x. -1 times 2 is -2x. And -1 times -1 is +1. Combine your like term. Bring down your x minus 2. So 4x squared minus 4x plus 1. Okay? You got a binomial and a trinomial. So what you want to do is take this first one times all of that. So x times 4x squared minus 4x plus 1. Take your next one times all of that. Minus 2. 4x squared minus 4x plus 1. Okay? Distribute, multiply. So now you have 4x to the third minus 4x squared plus x minus 8x squared plus 8x minus 2. Check your math. Okay, let me check my math to make sure I've done everything right. Good. Combine your like terms with your highest degree first. 4x to the third minus 8x squared minus 4x. My apologies, that comes out to be 12x squared. X plus 8x is plus 9x minus 2. Okay? So here's my final answer. Let me write it a little bit better. 4x to the third minus 12x squared plus 9x minus 2. Highest to your lowest. You are finished. All right. On number 28, you have complex numbers. That means you got 2 of them. So if you will look at this one, okay, I'm going to rewrite this twice. So now I'm going to put x minus 4i times x plus 4i. Why? Because it is a complex numbers. There you also have a square root. So I'm going to take those twice as well because that involves complex numbers. So x minus square roots of 3, x plus square roots of 3. Just like that. Distribute them out. I'm going to do these two together, and then I'm going to do these two together, and then I will combine them. Okay? So, x times x, x squared. X times positive 4i is plus 4 or 4xi, either way, minus 4ix, okay, you can write it xi or ix. I like this one better than this one, minus 16i squared. Do you see that? Same thing, x times x is x squared, x times square root of 3 is plus x square roots of 3 minus x square roots of 3. Square root of 3 times the square root of 3 is just 3, which is square root of 9, which is 3. All right, that cancels out, that cancels out. So now you have x squared minus 16i squared times x squared minus 3. I squared is the same thing as negative 1. So what is 16 times negative 1? Positive 16. So x squared plus 16 times x squared minus 3. Okay, distribute some more. X squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. 16 times x squared is positive 16x squared. 16 times negative 3 is negative 48. So that leaves you with x to the 4th, combine like terms, plus 13x squared minus 48. There you have number 28. 29, we're going to start into factoring. Count how many terms you have and see if you have any greatest common factor. Nothing goes into 9, 6, 3, and 2. So, since there's 4 terms, 1, 2, 3, 4, group the first 2, group the last 2. What do these two have in common? 3m squared. So you're going to factor out 3m squared. When you do, you have 3m plus 2. Keep that sign. What do these two have in common? Just a 1. When you factor out negative 1, you have 3m plus 2. Do you see how these two are alike? We write them as 1. Do you see how these two are the leftovers? Put them together. 3m squared minus 1. Can you simplify that anymore? Nope, so there's your final answer for that one. Okay. Number 30. Count your terms. 1, 2, 3, 4. Nothing goes into 1, 2, 2, 2, and 4 except 1. Group the first 2, group the last 2. What do these two have in common? 2n squared. Factor out 2n squared, so you have 2n minus 1 plus, factor out a 1, 2n minus 1. See how these two are alike? Put them together. The leftovers, 2n squared plus 1. Can you break this down any more? Nope. You're not solving, so you stop right there. Number 30. 31. You are going to factor each one completely. So, here we go. 3 terms, 1, 2, 3. This one, second term, is half of the first exponential. So draw your 2 sets of parentheses. What are from factors of a to the 4th? A squared, a squared. 2 numbers that multiply to give you 60 and is going to add to give you negative 16. What are those 2 numbers? 10 and 6, and both of them are negative. Okay. Can you simplify that any more? Nope, so that's your final answer. 32. Factoring. We're not solving, we are factoring. Second term is half of the first. See the exponentials? Draw 2 sets of parentheses. Factors of x to the 4th is x squared, x squares. What are 2 numbers that multiply to give you negative 15 and is going to subtract to give you positive 2x? Negative 5 and, positive 5 and negative 3. There we go, because we want a positive 2x. So plus 5, negative 3. Can you make that any smaller? Nope, you are finished. Okay. Using radians, find the amplitude and period of each function. Well, let's take a look. Here's the equation. Y is equal to A times your sine or cosine, bx plus c plus d. Okay, so make sure you remember that. This one is your vertical shift. This is up and down. There's your vertical shift, up and down. This right here is your period change. This here is your phase shift. That's going left and right. And here is your amplitude, which is always your radius every single time. So, knowing that, you can find out what these are. All right, number 33. It says, using radians, find the amplitude and period of each function. Well, the amplitude is 5. And I know it says period. And period, if you will look, is always, period, is always 2 pi over your b, and your b here is a 4, okay? So 2 pi over 4, so it's pi over 2. And then it says, find the amplitude and period of each function. You know what? I'm going to go ahead and add the vertical shift is up 1. So there are the 3 things I would like you to know. I went ahead and add the vertical shift. All right. Number 34. Here we go. Your amplitude is this 2 right here, always in front of the cosine. Your vertical shift is the plus and your minus, which is negative 2. Your period change is always 2 pi. Why 2 pi? Because a whole circle is 2 pi divided by 1 over 8. Can't have a fraction, so you got 2 pi. Change that to a multiplication. Take your reciprocal, 8 over 1, so it comes out to be 16 pi. It will take 16 pi to graph 1 cosine. That's what that means. Number 35, you are to graph each function using radians. Alrighty, so here we go. So your vertical shift is 1. Your amplitude is 2. Your period change is 2 pi over 1. There's not a number there, so it comes out to be 2 pi. Make yourself a little small sketch. So you got 0, and you have 2 pi. We are graphing sine. Okay, here's the halfway mark, which is your pi. Sine starts at 0. It's positive, so it goes up, comes down, and stops at 2 pi. Now, let's take a look at our graph. You're going to translate this part over here. So, we're going to vertical shift up 1, draw a really dark line, up 1. Your amplitude is 2, 1, 2, draw your dashes. 2 up, 2 down. Okay? Now you can make your graph. Start off at 0. At pi, we are at the axis again. At 2 pi, we are at it again. 3 pi, so it just kind of continues. Halfway between these two is your maximum. Halfway between these two is your minimum. And then you kind of see a pattern. See it? Then you can just graph your cosine. Okay? Try to make it curvy. Mine didn't look very curvy, but right there. So there you have your cosine. I'm sorry, your sine. That's your sine. Okay? Now let's take a look at our cosine. All right, here we go. Vertical shift is negative 2. Your amplitude is 4, and your period change is 2 pi over 1, which is 2 pi. I'm going to make my little sketch. 0, 2 pi. Here's pi. Start at the top, come down, go back up. So it looks something like this. Okay? Alrighty, let's go ahead and shift down 2. Draw a really thick line. Your amplitude is 4. Go up 4. 1, 2, 3, 4. Down 4. 1, 2, 3, 4. Alright, let's go ahead and graph. At 0, you're at the maximum. 2 pi, you're at the maximum. At pi, which is halfway, you are at the minimum. So, if you take a look, what's the halfway point here? So you're going to start at the top, halfway is middle, down, middle, up, middle, down. And you kind of see how it's a repeated pattern. Now connect. Okay. Just like that. Try to make yours look better than mine by making a U. just like it. Okay? So there you have your function. What does it mean from 0 to 2 pi? You graph a function. 1. No repeat. Okay, now you are to write an equation for the following. Here is the formula. Y equals A times your sine bx plus c plus d. Okay? So you should be able to graph, and now you're going to go in reverse. So let's take a look. First of all, try to find the middle, right here. What do you think your d is? Well, you went up 3, so I'm going to write a plus 3. Okay? Your amplitude is 2. You guys see that? So y is equal to 2. Now, look at this right here. You see how you're going down and coming back up? From 0 to 2 pi? If I went this way, that's a sine, but since I went in the opposite direction, this becomes negative sine. Okay? Was there a change? We look at between 0 and 2 pi. How many sine functions did you graph? Just one, so all you have left is a theta. So I'm going to rewrite this. Y equals negative 2 sine of theta plus 3. Okay? You move up 3, amplitude is a negative 2, sine function between 0 and 2 pi just occurs one time. It's repeated once. So there you have that. All right? 38. Take a look at this one. Where is your axis, your new axis? Right there. So you actually went down 1. So y is equal to minus 1. Alrighty? Now take a look. Between 0 and 2 pi. Did you guys see that? What function is that? That is a cosine. How many times do you see it repeating between 0 and 2 pi? Just once. Your amplitude is 1, 2, 3, 4, 5. And you're starting the positive, so that'll be a positive. Double check. 1, 2, 3, 4, 5. So to make it prettier, let me rewrite 5 cosine theta minus 1. Okay? So there you have your number 38. Good luck. I know you guys will do great. And just make sure you study hard. Thank you.